Today we're going to learn how to name compounds. And in order to do this, we're going to always ask ourselves, what is in my compound? How I'm going to accomplish that is I'm going to make sure that I have a periodic table on hand, because we learned where the group A metals were located on the periodic table. We learned where the metalloids were, the transition metals, and the group A metals. All right, so make sure you have a periodic table there on your desk. You should also have a copy of the concept map, because we're going to learn how to read from that. And probably you need the back inside cover, your textbook, for your polyatomics, or a sheet that has polyatomics on it. All right, so when we're naming compounds, remember, every time we look at a compound, we're asking, what is in my compound? And that periodic table is going to help you answer that question. We're looking at group A metal compounds, so those are metals in the group 1A and group 2A, as well as aluminum. And we're looking at those either being attached to a nonmetal or to a polyatomic. So let's take a look at these examples I have on the board. When I come to this first compound, I notice that it's a group A metal attached to a nonmetal. On your concept map, it says name the metal, and then name the nonmetal with an "ide." So Na, name the metal, is sodium, and then name the nonmetal with an "ide." So I'm going to change the ending of chlorine to chloride. Okay? Let's go to the next one. It has calcium and fluorine in it. Again, I know it's a group A metal attached to a nonmetal. The rule says name that metal and then name the nonmetal with an "ide." All right, so it's calcium fluoride. Any compound that has aluminum in it usually gets that incorrect, students do, because they forget that that's a group A metal, even though it sits by the metalloids. So because it's a group A metal, you're going to name that metal aluminum. And then let's see, that's oxygen. I wonder how I would change that ending with an "ide." What do you think that sounds like? That's right, aluminum oxide. Good. All right, let's take a look at this one, magnesium phosphorus. Remember, every time that I come to a compound, I'm looking that it's a group A metal. I'm finding that on the periodic table. And then I'm finding what it's attached to, and this is a nonmetal. So we're going to name that metal, which is magnesium. And then phosphorus, remember we have to change that ending to an "ide," and that's kind of a little tricky on that one, but it sounds like this, phosphide. All right, so we have magnesium phosphide. So all of those are group A metals attached to nonmetals. Now let's take a look at group A metals attached to polyatomics. I'm going to go to these middle two, or the middle and the end one first. All right, on the concept map it says name the metal and then name the polyatomic. If you don't know those polyatomics, they're just going to look like sulfur and oxygen. It won't have a meaning for you unless you can memorize those in the back of your book, or so you can recognize them. All right, so I recognize that an SO4 is a polyatomic, and I read that concept map that says name the metal, name the polyatomic. So this is potassium, and then that polyatomic is sulfate, potassium sulfate. All right, we're going to go down to here to the lithium compound. Again, if you don't recognize this as being a polyatomic, you'll see it as a carbon and nitrogen, but it really is one of those polyatomics back there. So the rule is name the metal and then name the polyatomic, and this is cyanide, lithium cyanide. All right, now let's go back up to this first one. My former chem students have told me that when you see parentheses in a compound, you know that that's a polyatomic. You may not know the name of the polyatomic, but you know that a polyatomic is in those parentheses. Okay, so I know that that's a polyatomic, that's my clue. So again, following the rules, I'm going to name that group A metal, and then I'm going to name that polyatomic. OH is a pretty common polyatomic. It's called hydroxide, and all bases are made up of OHs. All right, so these are just a little bit more challenging in recognizing the polyatomics, but follow those concept maps, follow the periodic table, label what's in your compound so you know what side of that concept map you should be working on. All right, as I gave you that tip, having the parentheses with the polyatomics, just recognize that not all compounds have those parentheses in it when it has a polyatomic. It's just one of those tips that former students of mine have now given to me to give to you. So let's work on some examples.